Number 10. The red giant problem is more dangerous than anyone talks about. In roughly 5 billion years, the sun will exhaust its hydrogen fuel and begin expanding into a red giant. Most people have heard this fact and mentally filed it under "not my problem." But here's what most people do not realize. The actual danger begins hundreds of millions of years before the final expansion. As the sun gradually brightens over the next billion years or so, surface temperatures on Earth will rise to levels that trigger what scientists call a runaway greenhouse effect. Liquid water evaporates permanently. The oceans are gone. The planet becomes uninhabitable to complex life long before the sun physically engulfs it. Planetary scientists modeling stellar evolution have calculated that the habitable zone around our sun is already moving outward. Earth sits near the inner edge of that zone today. The window for life as we know it is closing on an astronomical timescale, but it is closing. What this implies is that any civilization capable of surviving long enough to call itself truly advanced must eventually move its population off its home planet or engineer its planetary environment on a scale that defies our current comprehension. The fact that we have no evidence any civilization has ever done this, and no roadmap for doing it ourselves, puts this squarely in the category of a potential filter ahead of us. Number 9. Gamma-ray bursts turn the galaxy into a shooting gallery. Gamma-ray bursts are among the most energetic events in the known universe. When a massive star collapses into a neutron star or black hole, or when two neutron stars merge, the resulting explosion releases more energy in seconds than our sun will release across its entire 10 billion year lifetime. The beam of radiation released during a long-duration gamma-ray burst is so intense that if one were directed at Earth from within several kiloparsecs, it could strip away significant portions of the ozone layer in a matter of seconds. Some researchers have proposed that a gamma-ray burst may have contributed to one of Earth N's mass extinction events, possibly the late Ordovician extinction around 440 million years ago. But the real statistical argument here concerns the galactic distribution of these events. The inner regions of the Milky Way experience far more gamma-ray bursts than the outer regions where Earth sits. Astrophysicist James Annis and later Tisvi Piran have argued that for most of galactic history, the rate of sterilizing gamma-ray bursts may have been high enough to reset complex life repeatedly across large sections of the galaxy. Only relatively recently, as the galaxy has aged and massive star formation rates have declined, has the gamma-ray burst frequency dropped low enough to allow civilizations to potentially survive long enough to become spacefaring. This means we may have arrived at a temporary window of safety, and it also means that any civilization in a denser region of a younger galaxy faces this filter in an especially brutal form. Number 8. Artificial intelligence represents a convergence point with no historical precedent. Every technological civilization, by definition, will eventually develop increasingly capable computational systems. This is not a value judgment. It follows from the nature of scientific and technological progress. The argument here, formalized in various forms by researchers including Nick Bostrom, and more recently reinforced by developments in machine learning, is that once a civilization creates general artificial intelligence that surpasses human-level cognition, the trajectory of that system becomes difficult or impossible to predict or control using the same intelligence that created it. This is not science fiction speculation. It is a structural argument about optimization processes and goal alignment. A system optimizing for a given objective with superhuman capability may pursue that objective in ways that are catastrophically misaligned with biological survival. The concerning aspect from a great filter perspective is this: we have no examples in the fossil record, no signal in the cosmos, no artifact, no megastructure that suggests any prior civilization navigated this transition successfully and then continued to expand visibly. The absence of evidence for post-technological civilizations doing anything at all in the universe is consistent with the idea that the development of advanced artificial intelligence typically terminates civilizations rather than amplifying them. Number 7. Biotechnology creates extinction-class weapons that become progressively cheaper. For most of human history, weapons capable of causing mass death required the resources of nation-states. Nuclear weapons still do. But synthetic biology is following a cost curve that mirrors early computing. The tools needed to engineer dangerous pathogens are becoming cheaper, more accessible, and more user-friendly at a pace that outstrips our ability to develop governance frameworks around them. Researchers studying biosecurity have pointed out that unlike nuclear weapons, which require rare physical materials and large industrial infrastructure, engineered biological agents can potentially be created in modest laboratory settings. The concern is not just state actors, but small groups and eventually individuals with the technical knowledge and destructive intent. The great filter implication is straightforward and terrifying. If every sufficiently advanced civilization eventually produces the technical knowledge to engineer pathogens capable of threatening its own species, and if only a small fraction of individuals within any civilization need act on that capability to cause a civilization-ending event, then the mathematics of probability over time become very unfavorable. One successful catastrophic release, engineered for maximum transmissibility and lethality, could plausibly reduce a global population past a point of civilizational recovery. Number 6, climate tipping points may operate on timescales that outrun political systems. The scientific understanding of climate tipping points has matured significantly in recent decades. We now have strong evidence for the existence of threshold effects in the climate system, points at which feedback mechanisms become self-reinforcing and cannot be reversed by reducing emissions. These include the destabilization of the West Antarctic ice sheet, the dieback of the Amazon rainforest driven by reduced rainfall, the thawing of permafrost releasing stored methane, and the weakening of major ocean circulation systems. What makes this particularly relevant to the Great Filter argument is not just the severity of these outcomes, but the mismatch between the timescale on which they operate and the timescale on which democratic governments can coordinate action. Climate systems respond over decades and centuries. Political systems respond to election cycles measured in years. This temporal mismatch creates a structural vulnerability that is arguably inherent to the type of civilization we have built. The filter here may not be the climate itself, but the deeper problem it reveals that the organizational structures required to manage existential risks operating on long timescales may be fundamentally incompatible with the short-term incentive structures that govern complex societies. Number 5, nuclear war remains an extinction-adjacent risk with startling regularity of near misses. The scientific case for nuclear winter has been strengthened substantially since its original formulation in the 1980s. Modern climate modeling suggests that a large-scale nuclear exchange between major powers could inject enough soot and particulate matter into the upper atmosphere to reduce global temperatures by several degrees for years, collapsing agricultural systems worldwide and causing famine on a scale that would dwarf any historical precedent. Studies published in journals including Nature Food have modeled scenarios where even a regional nuclear conflict between smaller nuclear powers could reduce caloric production globally by catastrophic percentages. The great filter dimension here is not just the severity of the outcome, but the historical record of how close we have come. Multiple documented incidents during the Cold War involved nuclear launches that were either accidentally initiated or nearly authorized based on false information. In at least one case, a Soviet officer named Stanislav Petrov unilaterally decided not to report what his instruments indicated was an incoming American strike, a decision that may have prevented a retaliatory launch. The argument this supports is that maintaining nuclear arsenals across long historical timescales while geopolitical tensions fluctuate means the probability of accidental or intentional use approaches certainty over centuries. Number 4, resource depletion and civilizational complexity may have built-in collapse dynamics. Archaeologist and complexity theorist Joseph Tainter's work on civilizational collapse identifies a structural pattern across historical societies. As civilizations grow more complex, they invest increasing resources in maintaining that complexity. Over time, the marginal return on additional complexity investments declines. Eventually, the system reaches a point where it cannot generate enough surplus to sustain its own organizational infrastructure, and collapse occurs. Tainter documented this pattern across the Western Roman Empire, the Maya, and the Chacon Society of the American Southwest, among others. The relevant scientific extension of this argument involves resource constraints on a planetary scale. Economic ecologist researchers have modeled how industrial civilization depends on resource flows, particularly energy-dense fossil fuels that took hundreds of millions of years to accumulate and are being consumed in centuries. Transitioning to renewable energy before critical thresholds are crossed requires a level of coordinated civilizational investment that the historical pattern suggests may be beyond the organizational capacity of complex societies facing declining marginal returns. This does not guarantee collapse, but it identifies a structural vulnerability that appears to be universal rather than unique to any particular civilization. Number 3, the statistical silence of the universe may be the most important data point we have. The Fermi paradox has been discussed in various forms since physicist Enrico Fermi asked at lunch in 1950 where everyone was. The silence is the evidence. Given the age of the universe, approximately 13.8 billion years, and given that billions of stars similar to our Sun formed billions of years before our own solar system, there has been more than enough time for a technological civilization, arising even 1 billion years before us, to have spread across the entire observable galaxy. The fact that we see no evidence of this, no megastructures, no Dyson spheres absorbing stellar energy, no signals, no artifacts, no modified stellar populations, is a data point of extraordinary significance. Astronomer Frank Tipler and others have argued that the silence is so profound it constitutes strong evidence that we are alone, or very nearly so. If civilizations routinely survived and expanded, we would expect to see the fingerprints of that expansion written across the cosmos by now. The absence of those fingerprints implies that something terminates civilizations before they reach the stage of visible cosmic expansion. Given that we are not yet at that stage, Whatever terminates, civilizations may very well still lie ahead of us. Number 2, no detected Kardashev type 2 or 3rd civilizations, despite billions of years of opportunity. Physicist Nikolai Kardashev proposed classifying civilizations by their energy use. A Type 2 civilization harnesses the total energy output of its star, perhaps via a Dyson sphere or equivalent structure. A Type 3 civilization harnesses the energy of an entire galaxy. These are not purely theoretical fantasies. The physics allows for them. The time available for them to have developed is vast. Astronomers have actually looked. The glimpsing heat from Alien Technology's survey, known as GHAT, analyzed data from the WISE infrared telescope, examining over 100,000 galaxies for the waste heat signature that would be produced by a civilization harvesting stellar energy at scale. The result was essentially null. No confirmed candidates. 0 Type 3. Civilizations detected across a sample representing billions of years of independent evolutionary and technological opportunity. This null result is arguably the most scientifically rigorous piece of evidence we have that technological civilizations do not survive long enough to reach that scale. Since we are currently a Type 0 civilization on Kardashev's scale, the transition from where we are to where we would need to be to show up in that survey represents an enormous range of possible filters, most of which remain ahead of us. Number 1, the mathematical logic of the Great Filter itself points forward. Robin Hansen's original formulation of the Great Filter argument in 1998 begins with a simple premise. We observe that the universe is not teeming with visible advanced civilizations. Therefore, something filters out civilizations. The central question is whether that filter lies behind us in evolutionary history, meaning we got through it, or ahead of us, meaning we have not faced it yet. The hopeful interpretation is that the filter is in the past. Perhaps the emergence of eukaryotic cells, or the development of multicellular life, or the evolution of general intelligence, was so improbable that Earth represents a genuinely rare exception. But here is what makes this argument so scientifically sobering. Every piece of evidence suggesting that life and intelligence emerge more easily than we thought makes the future filter interpretation more likely, not less. If the discovery of microbial life on Mars or Europa were announced tomorrow, it would not be cause for simple celebration. It would imply that the emergence of life itself is not the filter, meaning the filter, whatever it is, still lies somewhere between simple microbial life and a spacefaring civilization with a long future ahead of it. We are somewhere along that path. The evidence has not yet told us we are past the worst of it. The silence of the cosmos, the absence of our technological predecessors, the null results of our most sensitive searches, all of it points in one uncomfortable direction. Whatever has been stopping civilizations from reaching the stars may be something we have not yet encountered. If any of this keeps you up at night the way it keeps scientists up at night, subscribe. Next video we are going deeper